Hello and welcome, everyone. Welcome to the Pet Food Summit by Wisenetics, an event specially designed for pet nutritionists and professionals across the industry. Today, we'll explore the latest research and insights from some of the world's top pet food suppliers and scientists. Our goal is simple: to give you access to the most current, evidence-based knowledge in companion animal nutrition without having to leave your home. We hope that this event helps prepare you for the challenges and opportunities shaping our field. I'm Dr. Kate Scheffler. I'm a professor of comparative nutrition at the University of Guelph and your host for today. On behalf of the Wisenetics team, thank you for joining us. We're thrilled to have attendees tuning in from across North America and the world, and maybe even in parts that we haven't hit before. Please feel free to share where you're joining us from in the YouTube chat because we'd love to see where everyone's watching. I'd also like to extend a special thank you to our sponsors, BioOrigin, Chem and Nutrisurance, and Stratum Nutrition for making today's event possible. And of course, a huge thanks to our guest speakers who bring a wealth of experience and expertise that I know will spark important conversations today. Remember, if you have any questions during the talks, just type them into the chat and we'll address as many of them as possible after each session. So without further ado, let's get started. It is my pleasure to introduce our very first speaker, Dr. Erin Perry from Southern Illinois University. Dr. Perry will be discussing dietary variation to enhance canine gut health. Welcome, Dr. Perry. It's a pleasure to have you with us today.
Well, thank you so much, Dr. Scheffler, for the invitation. What a fantastic opportunity and a great forum. I'm really excited to participate today.
Well, great. I'm so excited, and you know that you know me personally, so you know I'll be preparing my own questions for after your talk too, Erin. So without further ado, the floor is yours.
Okay, great. Thanks. Welcome, everyone. Super excited to be here today. This is absolutely one of my favorite topics. Managing gut health in working dogs and understanding how not only what we feed them, but the way that we feed them impacts their performance. That is a topic and a question that I find myself pondering more and more lately. And so I'm really excited to hear what the other speakers have to share with you today. And you've got some pretty smart cookies lined up to talk. So I'm looking forward to listening. I'm going to spend a little bit of time today talking about what we know. I'm going to spend a lot of time talking about what we don't know. We have a lot of questions that persist in the world of working dog nutrition. And I think everybody probably understands that the job they do is pretty important. So let's go ahead and dive in and kind of start with how we even begin, to kind of think about nutrition and gut health in working dogs. So probably no surprise to anyone watching this, you can't get a bunch of nutritionists together without looking at least a couple photos of poop. So this is kind of where it starts for working dog handlers and those of us that are in the field with these dogs. Fecal consistency is something that is continuously assessed, and it's one of the very first indicators that a handler may use to be able to assess if there's some kind of problem. We don't have time today to go into, transit time and, different color variations and things like that. But this is definitely, even if you're not a professional dog handler, this is definitely, one of those factors that even just companion dog owners, when they see something that doesn't look right in their dog's stool, it definitely is one of the first indicators that we use to be able to, start to ask questions about what we might need to change. And so we've started to link fecal consistency and variations in feces and start to try to understand what that might mean in terms of microbial fluctuations. I am super confident that everybody on this call and everyone that is attending this meeting today understands how important the microbiome is, to gut health. But it's really more than that. It's much more important than just diarrhea and gut health. It impacts the whole body and the entire wellness of the animal. And when you're talking about a dog whose ability to perform its task may actually be life and death for either their handler, if it's a medical alert dog, their ability to be able to successfully execute their trained final response and alert to diabetes or some kind of a blood glucose change. Those kinds of tasks require mental clarity and cognitive processing. And so we're starting to learn more about how the microbiome impacts more than just the gut, but it actually impacts the entire body. I think everyone understands immune function and pathogen protection. All of the things that we've got listed here, we've had some really, really brilliant minds looking at, pre and pro and symbiotics, lots of research out there. And so it's really exciting to start to see this field really kind of coalesce and move forward. And so, as I mentioned, in working dogs, we use that fecal score very, very frequently to be able to, kind of indicate, what's going on with our dogs. A lot of research out there regarding different types of fiber therapy and potential benefits that may be derived there, for the dog. The problem that we have is that very, very frequently working dogs experience intermittent, sometimes it can actually be very frequent, and sometimes it is sustained episodes of diarrhea. Now, I'm not talking about clinical illness. I'm not talking about a viral or a bacterial circumstance. I'm talking about a non-specific loose stool diarrhea episode. And that is very difficult to manage, because if you have a working dog that is a partner and that involves travel, sometimes it involves air travel, sometimes it involves travel with the team, and so you may not necessarily be able to stop with the frequency that your partner might need. And so managing GI distress under those kinds of circumstances, it can be very challenging. And if you have a dog who's suffering from that kind of problem and you can't get that under control, it actually can mean that dog is pulled out of service, which means now we've lost a resource in the field. Within the United States, we've had testimony in front of Congress because we have a documented shortage of appropriate working dogs from within the United States. And so if we're pulling dogs out of service because we can't manage GI conditions, that's a big problem. And it's something that we need to get in front of. And so I started thinking about this problem. And sometimes there are things that we know are very likely to result in GI upset in our dogs. And one of those things very commonly is an abrupt diet change, an untransitioned diet change. And we know that's going to happen sometimes. Sometimes it's a resupply issue. We can't get the same diet that the dog is used to. Sometimes there's a concurrent medical circumstance and the dog needs to be transitioned to something else. There's a whole variety of reasons why that just for under some circumstances, the dogs have to be moved to another diet. And I started thinking about, if we have that circumstance, how can we potentially mitigate that GI condition that we know is very likely to happen? And so I took some of the information from some of the published work that had been done regarding supplemental fiber and some of those benefits that occur within the microbiome and the subsequent benefits to the fecal scores of those dogs. And I started wondering, if we front load those dogs with that fiber before that kind of precipitating event, would it be possible potentially to either prevent or reduce the incidence of the GI distress in those dogs? And so we put together a small kind of pilot study, and we had two groups of dogs, and half of them got green beans as just a supplemental, very common, easy to acquire supplemental fiber source, and the other dogs they stayed on the test diet with no supplement. And what we found was that the dogs in the control group, 50% of those dogs, as expected, had conditions or clinical indicators of GI distress associated with increased fecal score. Interestingly enough, the dogs that received the prophylactic fiber, the green bean supplemental therapy, at the same time, simultaneous to the delivery of the challenge diet, only 2 of those 9 dogs actually had increased fecal scores. So we felt like that was some really good kind of early data to be able to continue this line of thought. And so we wanted to take it to the next level, because we wanted to be able to, how do we train that gut? How do we teach that system not to overreact when we have these fluctuations, when we have these disruptions? The one thing that is constant throughout the working dog world is that they are perpetually going to be dealing with variety and change, different environments, different geography. Sometimes they have to travel, different water, different climate, lots and lots of variation in those dogs' world. But the one thing that doesn't vary is their diet. And so I started wondering, are we maybe doing it wrong? Are we maybe preventing that system from being able to kind of learn how to tolerate and learn how to respond more appropriately to small, minor changes that would occur if you had some variety within the diet? And so we put together a small project. And again, this was less than 20 dogs. I think we had 18, 19 dogs enrolled in this project. And what we wanted to explore was, if we initiate a system where we have dietary diversity that is purposely included in these dogs' diet, does that equal GI diversity, which most people would suggest actually it would be a more healthy ecosystem? Diversity in ingredients, there's some enrichment potential there because it prevents that food boredom that has sometimes been anecdotally recorded. And so we worked with a Labrador retriever specifically because we didn't want any breed impact there. Really well maintained, well managed, very healthy dogs out at the Search Dog Foundation. Really, really high quality basal diet. All of these dogs were in phenomenal shape. And we took half of the dogs and left them on the control group, and the other half got rotating ingredients. For 1 week, they got one ingredient, and every week the ingredient changed. 3 of them were animals based, and 3 of them were plant based. Very, very simple study. We ran this study for 90 days because we really wanted to be able to measure the impacts, both good or bad, in the system. And as I mentioned, conventional wisdom would sort of suggest this might not be a good thing, because we've all been, kind of coached our entire lives. You shouldn't change their diet. That's not good for their system. And so I wanted to measure, biomarkers associated with inflammation or, any of those things that may potentially indicate this is unhealthy for the dog. We saw no statistical impact on C-reactive protein, calprotectin, or fecal pH. And so we felt like that's a pretty good indicator that the dogs were doing just fine from the control group to the treatment group, even after they had that same kind of non-transitioned dietary challenge that we used in the green bean study. But then when we looked at the actual taxa that were present, we saw some pretty surprising and some pretty cool results. What we found was that the dogs who were on the rotational diet, they actually had higher levels of Fecalibacterium, which many of you probably recognize as a very common probiotic, and they had lower levels of E. coli, which again, most of you probably recognize as a pathogen. And all we did was add, it was about a tablespoon, depending upon the ingredient. It was 10 grams. All we did was add one ingredient every week that was different than the control group. And we were able to beneficially impact the gut ecosystem. We felt like that was pretty cool, pretty easy to apply. And it definitely kind of furthers our interest in that question, which is, are we doing it right? Maybe we need to look at this in another way. Okay, so when we consider canine nutrition, Dr. Shoveler's group is doing some absolute world-class, some of the specific amino acid studies that they're doing specifically related to bioavailability and the way that we measure different amino acids and how we validate those measures and how we're able to then use those as predictive analyses for assessing whether or not requirements are being met. That is so incredibly beneficial, and that's definitely not something that I'm capable of doing. And I start thinking about, how do we take someone like her? How do we take someone like Dr. Cutler, who's working on some of these incredible supplement questions? How do we bring all of these people together? Kelly Swanson, who's doing these amazing microbiome studies, and Russ Kelly, who does some incredible work. He's done so much incredible work, and he's working with yeast now. And so we've got so many people in our industry that are so incredibly smart, working in all of these areas. And I think it really begs the question, how do we all work together? Because this is not just a working dog problem. This is a companion animal nutrition problem. We know specifically that dogs impact humans, period, full stop. Doesn't matter if they're dangling out of a helicopter or, chasing down bad guys. Dogs impact humans for the better. There are biological, psychological, and social benefits specifically associated with dog ownership. And when we kind of take it one step further and we look specifically at the microbiome, we know pet ownership changes the human microbiome. We actually share dermal microbiota back and forth with dogs when they are either in our home or when we directly interact with them. And that is an incredible, incredible piece of information. But it also is, in my opinion, indicative of the incredible responsibility that we have as nutritionists when we're formulating these diets, because we all understand the substrates within those diets drive the composition and abundance of that microbiome. And if we are then impacting the human microbiome for the individuals that those dogs are working with, that carries a significant responsibility, and that's something that we need to take very seriously. And so when we think about that, I think we have to consider very carefully, how do we separate and understand the unique differences between working dog specific nutrition and companion dog specific nutrition. The incredible advancements in AI we were just talking about, we were about that a little while ago offline. AI has become such an incredible tool, and it can be used for so many good things. If some of the work that's being done to be able to really fine tune some of these requirements, if we can start to build models that have more information regard to breed specifics, that have more information regarding hydration needs, that have more information regarding exercise models and fatigue and calorie requirements, that's going to improve our understanding just exponentially. And then obviously the next step then is, how do we test that? We continue to be frustrated because funding is always very difficult to come by for these types of projects, because these are these are not food production animals, and so the funding mechanisms for them are very, very different, at least within the United States. And so we would really like to see better collaboration across academia, industry, and agencies, so that we can all pool resources. There's so many questions to answer. Nobody needs to kind of recreate the wheel here. Let's make sure we're collaborating. Let's make sure that we're we're working together so that everyone can achieve that synergy. And a great place to start there would be the 2021 AHA guidelines on working dogs. There's some incredible information in there. It really defines very well the different categories of working dogs, the different ways they need to be managed, different needs with regard to diet because of intensity, duration, and frequency of exercise. Not to mention just some of the differences with regard to breed and the types of work that these dogs are doing. So I want to point out again, these dogs are incredible. And I know everyone's dog that sits on the couch with them, they're all incredible, and they're all, we consider them part of our families. But when you're talking about working dogs, they are making choices that can truly result in life or death decisions. And so the ability of those dogs to accurately and adequately have those decision-making skills is dependent upon their health and wellness. And that health and wellness, in my opinion, starts with good nutrition, mitigating stress, promoting maximum trainability. All of that occurs through the microbiome. There are so many studies in human medicine that are starting to look specifically at the gut microbiome and the way that it interacts with and impacts cognitive processes. Everyone understands the gut-brain axis, but we're starting to understand more and more and more just how closely interwoven all of those things are. We've actually done some pretty cool cognition work in our lab, and we can impact a dog's ability to have improved short-term memory just by changing the diet that we feed them. And so we definitely need to do a lot more work in this field, because these guys are responsible for the health and well-being of a lot of people who depend upon them. And so they depend upon us to get it right. And this is why it matters. This is one of my favorite examples. This beautiful dog, Blaze, was deployed to Haiti following the earthquakes there several years ago. And Blaze wasn't even supposed to be working. Blaze was just walking with her handler, and had finished the activities, had finished the searches, and was not given a command to search, and just took off running. In the dog world, we would call that intelligent disobedience, because the dog heard the command to come back and ignored the handler, and moved into an area where they were not supposed to be, and alerted on this little baby girl who was buried beneath a building. And they were able to tunnel through the wall, insert a camera, see that this little baby girl, who was 2 years old at the time, see that she was still there, still alive. And this was 7 days after the earthquake. Nobody should have been alive. She managed to stay alive by drinking drops of moisture that collected and were dropping down from the slab of concrete on top of her. That's the theory that the doctors have anyway. And Blaze found her. And so when we think about the impact of these dogs on every single day life, we owe it to them to get it right. And that's why I'm so incredibly honored to be here and excited to hear what all the other speakers have to say. Huge thanks to all of my incredibly brilliant collaborators who helped me share ideas and help me design studies to be able to answer these questions. And then even bigger thanks to the dogs, because they're the reasons why we all do this. Happy to answer any questions. I don't know where we are on time, so happy to answer any questions. Thanks, Kate.
Hey, no problem, Erin. Thank you so much for the really interesting talk. So maybe just a couple of questions from the audience, and I might jump in there with you too. The first one, and I like how it was posed, is dietary variation more about prevention or optimization?
Ooh, what a great question. I think it's maybe both. I think when you achieve a more optimal microbiome, you can actually prevent some of those dysbiotic type events that may actually result in some of the problems that we see So I think that potentially you could achieve both of those. What a great question. Yes, thank you.
Yeah. So, question, I'm going to have to bounce off that a little bit, Erin.
Okay.
Does the microbiome have um, what happens in terms of, like, I know that the microbiome has a kind of a homeostatic level, but does it respond long term to small threats the same way? Like, and I'm thinking about a hormetic response where, little tiny increments get you kind of prepared for the fight,
Right.
in essence. Is that?
Right. That's the exact theory that we're working
Hmm.
from. You know, and it's one of the reasons why probiotics have such a inconsistent rate of success in dogs, in my opinion. I think if you take a look at fiber supplementation, kind of more of a prebiotic type of approach, you will see better long-term strategies because the substrate that you produce actually drives the composition of the system. And so
Yeah.
if you're introducing small incremental differences, to your point, you can actually train the system not to overreact. Very similar to, when you take allergy shots, you're being introduced to those antigens in very small controlled doses, and you're
Mhm.
kind of training your immune system. Don't freak out, don't overreact. This is fun. It's going to be okay. And so if we can teach the gut system very early, and I'd love to be able to do this study in puppies, and so we're actually working on setting up a young dog study right now. If we can teach the dog's system very early to be able to tolerate those very small incremental disruptions and those types of events, would it actually yield benefits beyond just dietary disruption? What about travel stress? What about exertional stress? What about heat stress? All of which we know can cause significant impact to the GI system. And so we feel like there may actually be potential for broader health implications outside just managing, dietary disruption.
Yeah, there was another question, and you alluded to it. You did talk about fiber, and I was thinking as you went through that explanation that having adequate total dietary fiber for these dogs kind of is the foundation for the microbiome. And then there's the change part where that's kind of that's a different level of response criteria. But the question came in about, would probiotics rather than diet change have the same response?
Yeah, what a great question. And I think it would be impossible to answer that question without looking at the individual probiotics. Um, I think there are many probiotics that have been used medically under specific circumstances for very particular benefits, and there are certainly some very good and very well developed probiotic products on the market. I think the problem that I encounter specifically when I'm talking about working dogs, and I'm just going to kind of take this a little bit further because you set it up so nicely. When you're talking about dogs that have such a higher level or a higher requirement for calories, higher levels for specific amino acids, just because of the exertion and the different kind of muscle maintenance that has to occur there. I think the old school method of just feed them more, just add more fat, add more protein. I think in some circumstances, in some breeds, that actually results in higher incidences, higher frequencies of GI distress. And so, to your point, if we use fiber as the foundation for the diet, perhaps we can slow down that transit time a little bit. We don't necessarily have to increase to such crazy high levels where the feeding rate is 5, 6, sometimes 7 or 8 cups a day for some of these dogs. And, their GI system is just blowing it out so quickly. So if we can kind of reconsider fiber as a foundation, that kind of more complex carbohydrate, That's more of a prebiotic type of approach, but that will actually, in my opinion, then you have the potential to have the individual taxa contained within that system to be supported at a better rate. And now you don't have to add supplemental probiotics because you're doing a better job feeding the bugs that are already there. I hope that was kind of the right way to approach that. That's a great question.
Yeah, I think so. So maybe the last question, and it's a little bit complicated. So we'll try to be fairly focused, but do you think more specific formulation models could help the industry better understand how the microbiome reacts to diet changes?
I think that is a brilliant question, and I think that is exactly where the industry needs to go. And I actually just saw that one of your team had a new paper published on bioavailability, a new model for specific amino acid requirements. And what a great example, what a great framework for the way we should be approaching this. It's not just breed specific, it's lifestyle specific. If you have a vision assistance dog that travels with their owner, that sits in an office all day, that's constantly navigating, public transit and in and out of restaurants, it's literally going through everyday life with their owner. That's a working dog. That's obviously very different from a customs and border protection dog that's working in 110-degree weather down in South Texas. So those dogs, although they both have very, very high levels of cognitive processing that needs to be supported, their physical exertion, their environmental exposures are very, very different. It could both be Labradors, but they're very, very different. So new formulation models should actually account for those types of variation so that we can start to manipulate fat, fiber, and protein to support those needs with much greater accuracy. Love that question. That's where the industry needs to go, in my opinion.
Yeah, definitely. And really, it's just a form of precision nutrition.
That's it. That is it. Yeah, love it.
Exactly. So thanks again, Erin. Such a great way to get us started this afternoon. And please stick around for the rest of the speakers as well.
Will do.
All right. Okay, so next we are joined by Dr. Sarah Cutler from Chemin Nutriassurance. Today, Sarah will present Fat Facts and Food Safety Hacks, Game-Changing Solutions for Pet Food. Welcome to the floor, Dr. Cutler.
Oh, hello. Hi, you got me on here. Clicking on my slides here. Hang on. There we are. Okay.
Excellent. Everything looks great.
Cool. All right. Well, welcome everybody and good afternoon, I guess, depending on what region you're in. Really impressed to see people from all around the world interested in talking about pet food. And I'm going to specialize a little bit today. I'm going to talk about fat. I know that's probably not what you had in mind as a good time, but we think it's fun. I especially like to follow a talk where we talked about dog poop. As a microbiologist, I respect that. I'm glad to have a little opportunity to learn a bit more about that as well. So what I'm going to talk about today is as we look at pet food and as we look at palatability, and in our case, where we're looking a lot at shelf life stability, we really are concerned about ingredients that go into pet food. And what I'm going to talk about today is the impact of that enrobing fat. So, anytime that we make kibble, we're going to have some kind of enrobing fat on the outside of that diet. And since it's on the surface of that diet, it can promote that oxidation out on the surface of that kibble, and it can promote either very good or not so great aroma on the outside of that kibble. And usually, since I work for Chemin and it's been my career for the last 18 years, I would talk to you about oxidation, but I'm not going to talk about that today. Well, a little. There's always a little in there. I'm going to talk mostly about microbiology, and my background is a microbiologist as well, but we're going to talk a little bit more about backing up and looking at ingredient quality all the way back at the raw material. So when we talk about what impacts ingredient quality, there are these two sides. and one would argue a third side when we look at the protein ingredients and protein oxidation as well. But really, generally, we've got your oxidation side where that generates the byproducts that smell to a dog or a cat and that are a turnoff from that perspective. And from the microbial side, of course, animals, humans included, actually prefer ingredients that are fresher. So when we have that microbial degradation, I'm going to talk about the impact of it specifically in cat and dog food. I'm going to talk first about fat itself. As we know, fat is one of only 2 ingredients that is added in the extrusion process, post-extrusion, when we're making kibble. So that fat is put out on the surface of the kibble. Again, I'm talking about there are some exceptions, of course, where we will put that fat through the extruder. We'll add that fat into that kibble core. But when we're talking about that enrobing fat, it is really one of only 2 ingredients that is added on the outside of that kibble. The other thing that is added, of course, is palatant. If palatant is liquid, it is already acidified. If we're talking about fat, it's generally not, though. Common practice, however, has become to add something to that fat to prevent any kind of microbial recontamination, which, you know, one could argue it is fat. Fat doesn't actually grow salmonella, but it sure can carry it. So fat is very low water activity. Of course, ideally, you can have some moisture in there as well. But for the most part, fat that we use in kibble is very low water activity. But that fat can be handled a number of different ways. And it's been really interesting kind of collectively looking at all of the creative ways that we optimize that fat that we use. That fat can be heated, it can be acidified, it can be filtered, it can be refined. And for the most part, all of those processes will result in a high quality fat. What we're trying to prevent here, though, is that fat being a source of contamination in that diet or carrying a source of contamination to that diet. When we're talking about things that are higher moisture, and that these studies have been done and published, where when you have fat that is higher moisture or higher impurities, you can actually have that opportunity for more microbes in the fat. However, what we're talking about when we're talking about, let's say, a salmonella type situation in enrobing fat or carrying any kind of microbe in that enrobing fat, where that fat's going to encounter its risk really is in transport. When fat is produced at the rendering plant, it's very, very hot. After that, however, it is handled. So what do we do about that to prevent risk in that fat? How we do this most commonly is we add an acid. Well, acid is water, fat is oil. As we all know, oil and water don't mix very well. A better solution to that is to use a product that is emulsified. And of course, we have one that we prefer to use that contains a lactic acid as well as antioxidant. What I'm showing here in these charts is that impact of, even if you add an acidifier, I'm showing the impact of temperature. So that chart on the right is actually fat held at 90 degrees F. So during the winter months, all around the world, things have an opportunity to cool off. So if you're using heat to mitigate any kind of recontamination, that's where this becomes problematic, because if your fat has to travel a long distance, it's going to have the opportunity to cool off. If you add an acid after it has cooled off and goes into your system, what I'm showing here is the reduction in salmonella at these 2 temperatures. A little bit about our salmonella. The salmonella that we're using in here is actually a freeze-dried cocktail of salmonella versus our lactic acid containing product at these 2 temperatures. The chart on the left shows how quickly that salmonella can be mitigated. And this was a pretty high challenge level of 5 logs, but how quickly you can reduce the amount of salmonella in that fat at a higher temperature, 135 F versus 90 F. So if you see there really is that challenge of handling, as well as that acidifier needs to get where it needs to in order to mitigate that salmonella that may land in that fat. So that's a little bit on micro in the fat itself. But what I'd like to do a little bit more today is back up a bit further. So talking about free fatty acids. And I know that when we talk about free fatty acids, we're getting toward the fall, at least here in the Northern Hemisphere. The temperatures started to cool off now. Maybe free fatty acids aren't top of mind, but since we're just coming off of summer and all free fatty acid season, it does help to talk a little bit about where free fatty acids come from and their influence on pet food palatability, as well as its impact on shelf life. So free fatty acid impact on shelf life. So when we talk about free fatty acids, again, you're probably used to me talking about oxidation, but free fatty acids are actually a result of microbial degradation of fat. I've got a picture of a fish on here because when we talk about where fish oil comes from, we've got that fish raw material, that offal that goes through that process. Where we get the free fatty acids from in all species is the degradation of that raw material that goes into the rendering process. So if we want to do something to prevent free fatty acids, we really have to prevent them back at the raw material level. So free fatty acids are formed by lipases. These lipases are commonly microbially derived. And as we know, bacteria prefer to grow during summer months because their ideal growth temperature is 37°C or 98°F, nice and warm. And when we're talking about offal from fish or from chicken or from any species, it's going to contain viscera from that animal, and it's going to go from the slaughterhouse to the rendering plant. And that's really where we have the opportunity for those lipases to get going and the micro to get growing, and we generate free fatty acids. Another review here. So we've got these triglycerides from fat. We've got those spoilage bacteria. That time and temperature gives the two the opportunity to interact. And what will happen is you have that bacteria growing. It starts to chew on those fats. The fats get broken up into free fatty acids. And then after that, you really don't have the opportunity to do much about it short of filtering them out. So if the free fatty acids are in that fat, you're kind of stuck because it's going to be there through processing. You really can't get rid of them. Same thing, biogenic amines. Those free amino acids or amino acids that are present in that raw material get exposed to these spoilage bacteria. And there are bacteria specifically that generate specific biogenic amines. When those biogenic amines, and these are things like cadaverine and putrescine, things that really don't smell good because they're decomposition bacteria. Once those biogenic amines are formed, then you cannot get rid of them through processing. So from the pet food side and from an industry where we really are trying to be sustainable and we're trying to do our best to be good environmental stewards and use leftovers from human food production, we really do need to be judicious about the materials we use, but we also do need to be good about preserving those materials so we can get the most out of those ingredients that we can, and we don't end up having to dispose of them. Okay, so free fatty acids themselves, this is a chart. So again, we are located in Des Moines, Iowa. These were samples that were submitted to our customer laboratory services. You'll see, and again, we've got this time span from October to May where we're looking at free fatty acid levels from one supplier throughout the year. On average, you will see the free fatty acids really get to increasing about, well, May or so, and maybe decreasing again by September or so. So what that means is that raw material that goes into that rendering process has had the opportunity to degrade, and then the free fatty acids are coming through in that fat. So what you see is that increase during the summer months is the temperature increases and that raw material is transported and allowed to basically ferment and degrade. You see that increase in free fatty acids. And if you look at the level there, if you assume like a free fatty acid of 5 is a tolerable limit, you'll see a lot of samples well above a 5 in those summer months. So what do we do about that? First, I'm going to talk about the influence of this and why it is a thing, why free fatty acids are important, and then I'm going to talk about prevention of them. So we did a couple of studies. So my colleagues in Europe had actually done a very similar comparison in that region. I'm going to talk today about North America, a study that we actually did in the US, where we were interested after all of these years really what is the impact of free fatty acids on palatability of diets. So we had a couple of suppliers graciously send us some high free fatty acid fat. And what we did was blend that down to 4 different levels of free fatty acids. And then we just fed it to dogs and cats to see what they thought about those free fatty acid levels. Because we'd suspected and we'd heard for a number of years where the tolerable level should be. What we wanted to do is investigate that a bit for ourselves. So we took this high free fatty acid fat, 25% free fatty acids, and we blended it down versus a 0.5% control. So for each of these, we fed the 0.5% fat as well as different levels of free fatty acids to dogs and cats. First, I want to show you that at the time that we fed these, the oxidation of these diets was well under control. The peroxide values, again, were very low. The only variable really was the amount of free fatty acids in that enrobing fat. We had levels of natrox that were fairly consistent. Again, the diets were all the same. They were all treated the same, all made the same. And then we had hexanol and decadienol, again, those aldehydes that impact palatability from an oxidation perspective. We had those under control. And really the only change was the amount of free fatty acids that we fed those animals. So as you can imagine, and if you've been in the pet food industry for a while, you kind of know this, that cats have an opinion. Cats very much had an opinion in this matter. They very much did not enjoy any kind of increase in free fatty acids. What I love about cats is they very much told us what they thought. And if you have a cat, this is common with them. They did not like any increase in free fatty acids. So anything above a 5%, they're always going to prefer the lower level, that 0.5% fat. When you're looking at dogs, however, a little bit of a mixed bag there. And, I know that my dog probably is not a discerning consumer. He doesn't have a lot of opinions about free fatty acids or those sort of things until you get to a higher level. So what you see here is you do see a little bit of an opinion out of a dog. Once you get above that 10% to 15%-ish, you actually do see a little bit of a preference toward the free fatty acids. And we do know that dogs do enjoy free fatty acids to a certain level. But once you get above that 15%, even though they may actually eat this diet, again, this is at the initial time point, I'll show you what happens over time and why they may not actually enjoy the taste of these diets later on. So I'll just preview a bit that these higher rates of free fatty acids actually do cause oxidation in these diets. So even though the dog may like the taste of a high free fatty acid diet at the beginning, later on, those higher levels of free fatty acids are going to cause oxidation. And then you're going to have that flip in preference where the dog is not in favor of the oxidation byproducts that those free fatty acids promote. Okay, and that's what I've got here. So as we stored these diets, because we were interested in showing what happens to these diets' shelf life over time, we held them for shelf life up to 20 weeks or more, which is pretty typical. This is at accelerated temperature, so we do try to speed the reactions along a little bit. We did see that as you increased the amount of free fatty acids in that fat, those diets did oxidize a bit more quickly. And aldehydes is really what tells us this. So the aldehyde levels, as the antioxidant was depleted, the peroxide value increased, the aldehyde levels also increased. So what you see is over time, this decrease in shelf life with an increase in free fatty acid level. And what's causing that, and what I'm showing here on the cat diets, these cat diets, as you see that increase a little bit more slowly. Cat diets in general oxidize a bit more slowly. You see a decrease in that antioxidant that is added. And that's really what's happening. Over time, those free fatty acids are actually promoting oxidation in that fat. That enrobing fat condition is really important, probably the most important thing to the shelf life of that diet. Those higher levels of free fatty acids are driving that oxidation, and they're causing another problem, when that diet is out on the shelf, they're causing that aroma of oxidation. And this is the aldehydes for the cat diets. Cat diets in general do oxidize a bit more slowly. Cat diets tend to have a phosphate out on the surface that drives palatability. It actually helps preserve the diet a little bit too. Cat kibbles tend to be smaller, more dense, and we do add more fat out on the surface of a cat diet. Cats, again, at the higher free fatty acid levels, were already offended by the aroma of this. So I guess we don't have both things going on here, the oxidation and the free fatty acids. But again, cats have already told us what they thought of these free fatty acid levels. Okay, so a summary of that, across all diets, the fats that are lower in free fatty acids consume the least amount of antioxidant, and that's really important for diet shelf life. The diets lower in free fatty acids resulted in a longer shelf life of those diets. And again, this was apparent in those dog diets where we had that increased amount of free fatty acids reduced the shelf life of those diets. Okay. All right. So I've told you about the harm of having that free fatty acid fat on there. Now I'm going to tell you what you do about how to prevent the free fatty acids from occurring in that fat in the first place. So when we talk about free fatty acid prevention, there are a few things that go on when we do have off-all materials coming into a rendering plant that is high in microbial degradation products. It's actually more difficult to render that material. There are other things in terms of worker safety. We do want to make sure that we have fresher materials coming into that rendering plant. We've shown data before where if the raw material is preserved and we prevent the accumulation of things like ammonia and hydrogen sulfide, that's better for the raw material for the workers in the rendering plant. We also do want to avoid the accumulation of biogenic amines. Biogenic amines, again, are those decomposition aromas. We definitely do not want that in our dog and cat food. That would go with the rendered meal portion of it. When we're talking about the fat, we're really wanting to make sure that the free fatty acids are lower, again, for that oxidation and for that aroma or that flavor of the free fatty acids, preventing that from occurring in the finished diet. Okay, we're talking about preventing, move ahead. When we're talking about preventing free fatty acids, we're not talking just about chicken. We end up talking a lot about chicken in the US because we do use that as one of our primary ingredients. When we're talking about preventing free fatty acids, however, we are concerned with fish species, like I mentioned in the beginning as well. So we did a quick experiment where we added an acidifier product to that offal that is going into fish rendering, again, to try to prevent free fatty acid formation in fish. Fish oil, again, is another very valuable ingredient to the pet food industry, and we want to make sure that that product is in good condition as well. When we add this acidifier, we do drop the pH of that raw material. In dropping that pH, we prevent the microbes from being able to grow. It actually prevents them from metabolizing and prevents them from growing in that raw material. And if we add an acidifier, we drop that pH. What you're seeing here is either the maintenance of a low level of bacteria or even a bit of a drop in those microbe numbers. This are EB, or Enterobacteriaceae species. In general, as you acidify, you can actually keep that level a lot lower. And as we look at that, we can actually keep that pH lower in those materials for 24 hours. So that actually allows the rendering plant to be able to run that material after a duration. So you obviously don't want your raw material sitting around for very long, but in situations, particularly if this material is fished and then brought to shore and rendered, this helps to prevent the free fatty acids or that microbial decomposition of those raw materials before they're rendered. And thus that results in a better quality material for all of us to put into our pet food. I am going to talk a little bit about chicken as well. A study that we did just very recently, we actually added an acidifier product to chicken byproduct meal offal just A quick distinction here for if you may not be familiar with our rules in North America, at least in the US, we do have a distinction between chicken byproduct meal and chicken meal. Chicken byproduct meal contains head, feet, viscera of the chicken, whereas chicken meal does not. Therefore, chicken byproduct meal is actually very subject to microbial decomposition because it does contain that viscera ingredient in there. What we did was we treated that material as it was created at the slaughter plant. So before it had an opportunity to warm up, we then took pH measures to make sure that our acidifier was doing what it was supposed to, and then rendered that material. So you can see here is a bit of my chart got a little messed up there, but what you can see is a reduction in free fatty acids as measured by percent oleic in the meal in this case. We were wanting to reduce the amount of free fatty acids in that meal. And what I've got there is a time span where we started rendering it and then took samples while that material was rendering. And what you see is actually a very nice drop in free fatty acids over time. That's in the meal. Also looking at the putrescine, I talked about biogenic amines being important in those protein ingredients. What you see here as well is kind of a high amount of putrescine and cadaverine to start, and then a gradual decrease in those biogenic amines over time. And that's very important for palatability reasons. Both dogs and cats do not like the presence of biogenic amines in their dinner, basically in their meals. Even more impressive, perhaps, is the amount of free fatty acids that we can reduce in the fat itself. I've got, again, the controls, gray bars here at the beginning, and then that decrease in free fatty acids in that fat over time. So as we get that acidified viscera running through that system, we are actually able to reduce the amount of free fatty acids in that material over time. Material was 11% at the beginning, and by the time we were done, it was closer to a 4.9 free fatty acids. So that's, as we showed in the palatability data earlier, 4.9 is a lot more acceptable to an animal than 11%. Okay, so just to kind of summarize all of that, the free fatty acids and biogenic amines are the result of microbial breakdown of raw material. Both of these do impact palatability. And again, we've known that for some time with biogenic amines. With free fatty acids, we really needed to do this work to kind of identify where that limit is for cats and for dogs. And what we learned was that those free fatty acids do have an impact on shelf life, particularly in that dog diet. And of course, maintaining fresh ingredients is very important to us to limit these FFAs and biogenic amines. We can prevent the loss of some of these raw materials if we're able to keep them good in the first place. Okay, and I always like to end with, of course, pictures of my pets. Thank you to everybody in the pet food industry that is tuning into this for taking good care of Eli the cat and Bob the dog. And I'm happy to answer questions.
Great. Thank you for the fantastic presentation, Sarah. Not just jam-packed with data, but also very practical. And I also did not know that you have animals with human names. This is absolutely my preference all the time. This makes everything funnier in the household, right?
Yeah. Eli and Bob appreciate the respect due with a human name as well. Yeah.
I have to ask though, I feel like they may have been named after athletes.
No, actually, Eli was named after my husband's employer at that time.
Interesting.
And Bob the dog may or may not have been named for one of our former account managers at Kemin.
Okay. Oh, it's a good claim to fame.
Yeah.
I love it generally when I think that's a really big compliment when people name their animals after you.
Yeah.
I think it's good. Okay, so we have quite a few questions here in the chat. So I thought I'd lead off with how do specific dietary fat sources influence the canine gut microbiome? And could these microbiome shifts modulate risk factors for insulin resistance and diabetes?
Oh boy, I'm not sure what the fat influence on all of that would be. I know that the fatty acids that we use in pet food often are a skin and coat claim. I know that we target high linoleic type of sources of fat for a skin and coat claim. I'm not sure I'm qualified to comment beyond that.
Yeah, and please, I think it's Beatrice who asked the question. You can follow up. Indeed, for the most part, there shouldn't be a lot of fat entering the large intestine. That would be my first thought. And so what we usually do on something where there's inflammation tied is that becomes even more important to have those long chain fatty acids, in particular EPA. And if you think about everything that Sarah presented here, what that means is that if you have a diet that's targeting inflammation, diabetes, that you need a good fresh oil being delivered to that dog or cat to have that benefit. And
really what we're trying to do here is prevent refusal. So, the animal does not get the nutrition if they will not eat that diet. Yep. And if you have a cat and they just flat out reject that pet food, that is not good for their gut microbiome either.
Yes, because not eating changes your microbiome, and eating changes your microbiome. So there's also that interplay.
Yeah.
So maybe moving on to the next one. How do you see the relationship between ingredient freshness and final product palatability evolving in the next few years?
Yeah, we've really had a lot of interest in this. So the impact of the ingredients going into the diet impacting the final diet palatability. And I think that's absolutely become more important. For many years, we've talked oxidation products, and we did a lot of testing on, tying this oxidative byproduct to palatability and that sort of thing, but it really didn't factor in all the other stuff. So all the biogenic amines, all the other off aromas that go into that. I think that is very important. As we've gotten better at preserving the diet itself at the end, we need to back up and take care of the ingredients that are going in there, because that has just as big an influence. Definitely has an influence on palatability, because that 1% to 2% of that palatant that we put on at the end can help that initial aroma maybe, but after a while, you're not going to be able to overcome if you have an ingredient issue going into that recipe.
Yeah, out of curiosity, to build on that too, do we know all the off aromas that dogs and cats detect because they're so much better?
Oh boy,
yeah.
I know that our R&D group and our palatability group does GC analysis and very detailed compounding, looking at all of the peaks that are involved there. Yeah, that is definitely an entire science into itself. And I'll bet that we know there's a regional component in that. Some animals are used to smelling certain aromas versus other regions may not. My animals love cheese. Maybe if they're in another region, they wouldn't know that smell. So it gets really interesting.
Interesting. Okay. Next, great question. How does acidifying the raw material affect palatability?
Well, what we've seen is when we run these materials. So every time that we develop one of these acidifier type of things, we do a study where we over acidify, or we go crazy and we see if we can ruin palatability with it. We have not seen an impact in ingredient treatment with these acidifiers on final diet palatability. In fact, we see that not treating it can be a lot worse, right? So we know that if you exceed a certain amount of organic acid, then the dog and cat will smell that as well. So we definitely try to make sure that we're not using all the same acid through everything. So we're not just hammering everything with vinegar, for example. And then we make sure that we stay below that flavor threshold that might occur. But really, in general, most times where we run a preserved product versus something that is not, we see a bigger influence of a higher amount of biogenic amines or free fatty acids or oxidation than we do adding that acid. And we do use acids that are okay with cats and dogs too. We have pre-screened them with the animals to make sure that they're all right.
I would, the ag industry does a lot of work and is doing a lot of work with organic acids in feeds as well. Yep. So there are also physiological effects to adding
like a butyrate.
Yeah.
So, only butyrate's pretty smelly. So that's an example of something that would not be easy for us to use in pet food because it is pretty aromatic.
Yeah. And dogs really like butyrate, but humans do not. So
right, exactly.
There's also that.
Yeah, and we need to make sure that the diet can be in somebody's house, right? So we can't have that really smelly stuff in here.
Okay, so we will end it with this last question. How does different types of kill steps, so the difference between HPP as an example versus thermal processing or irradiation used in the industry for finished product, how does that influence the formation of free fatty acids? And they
when we're talking rendered meal, we're not really talking about any kind of irradiation in that ingredient so much. When we are talking about things that are more commonly irradiated, your freeze dried or your HPP sort of steps or radiation that's used in those steps definitely can promote oxidation. It's not through free fatty acids. It's more through traditional lipid oxidation. Yeah, certainly processing aggressively, you can promote some oxidation reactions that occur in there. So it's again important that you preserve that raw material with those sorts of steps in mind. So if you know it's going to be irradiated or if you know it's going through an HPP, then you need to protect that ingredient, like add that antioxidant and then add your preservative at the level that you're going to need it after it's through that processing so that there is some left.
Excellent. Well, thank you, Sarah. Every time I hear you speak, I learn something. It's always a pleasure. Thank you so much for joining us today and answering some questions too.
Yeah, appreciate the opportunity. Thank you.
All right, everyone. Well, we are running a little bit behind. So what we will do is we will take a 5-minute break and then we will return at I'm in Eastern Standard Time. I don't know where everyone else is, but we will return at 20 minutes past the hour that you are at, wherever you are, at least in North America. And I think globally, if you're joining globally. So I'll see you back in 5 minutes.
vision meets sound, where knowledge comes alive, bringing ideas that make you thrive. From the experts to the field, we bridge the gap, connecting minds with every word and every chat. We're the pulse of progress, the voice of the wise, sharing insights, sparking minds, opening eyes. From research to practice, we break it down, turning complexity into knowledge renowned. Get smarter, get sharper with every listen. Ideas that grow, perspectives that glisten. From the lab to the farm, we're making waves. WiseNet, it's where the future is paved. We're more than just stories, we're learning in action, helping you stay ahead with every interaction. From the ground up, we build the flow. WiseNet, it's the place where knowledge grows. From the lab to the farm, we're making waves. WiseNet, it's where the future is paved. WiseNet.
Welcome back, everyone. If you're just joining us, I'm Dr. Kate Shoveler, and I'm the host for today's Pet Food Summit. I hope that you're recharged with that quick 6-minute break and ready for our next session. Please continue posting your questions in the chat, and we will get to them after the presentation as we've done with the first two. Just another quick shout out to our sponsors, BioOrigin, Chemonutrisurance, and Stratum Nutrition. It's now my pleasure to welcome Marie Parks from Stratum Nutrition, who will present Woof to Whisper, Validated Microbiome Support for Oral Health. Welcome, Marie.
Hi, Kate. Thank you for the introduction. It's a pleasure to be here. Two great talks so far. So looking forward to everything to come. Let me click on this here. Okay. Alrighty. So I hope, everyone enjoys a little break, and I appreciate your time listening in, and hope I can provide you all with a breath of fresh air with some valuable learnings about our Stratum's unique probiotic for oral health. So just starting with some background on oral health as it pertains to pets and humans, just a little bit, because they do have a lot in common. And the ingredient I'm going to be talking about today does have research in humans as well as canines. So today, though, we will be focusing on the canine studies. And it seems like, at least the 2% so far, have their own dogs. And I'm sure a lot of the listeners have their own dog, or if you don't, I'm sure you've at least interacted with a dog where you've experienced an unpleasant odor when their face was near yours. And this makes sense when learning that about 80% of dogs have halitosis, or bad breath. So this chart here kind of provides an overview of oral hygiene in humans and pets. I couldn't find any reputable statistics on how many owners floss their dog's teeth, but if anyone does do this, I give them major credit. And similar to the large percent of humans that don't brush and floss, according to the ADA gold standard, a small 2% of owners brush their dog's teeth daily, with more than half of dog owners never having brushed their pet's teeth. And not only is this dog breath irritating to the nose, but bad breath can be a sign of more severe issues that are developing, with the risk of periodontal disease increasing, where 80 to 90% of dogs and cats have it as soon as age 3. And it's also the #1 diagnosed conditions in dogs. And 73% of those dogs have a related systemic comorbidity. And this is because in both humans and dogs, the bacteria that are causing the bad breath can transfer into the bloodstream and then travel to other organs, causing infections and inflammation, which can then lead to diseases of the heart, kidney, liver, brain, etc. So again, the causes of bad breath are similar in dogs and humans. One of the causes in both humans and dogs is the presence of bacteria on the teeth and tongue that produce volatile sulfur compounds known as VSCs. And these are the main bacterial culprits that are churning out VSCs are those that don't need oxygen, hence living in the oral cavity. So those like F. nucleatum and P. gulae in dogs. And then some of the more common VSCs that these gaseous bacteria are emitting are those like hydrogen sulfide, that has a characteristic smell of rotten egg, methyl mercaptan, which has a smell of feces, and dimethyl sulfide, which smells like rotten cabbage. And bad breath, some people might have the opinion that others have bad breath, but it technically isn't an opinion. It can be measured using a gas chromatograph. In levels above 0.15 parts per billion is what is the level of being considered that it causes discomfort to those around you or those around the dog. And as mentioned before, bad breath really isn't just unpleasant, but the involved bacteria can make existing dental issues worse and or lead to more severe health dangers. So before diving into OraCMU, the ingredient that I'll be talking about, this is a brief review of current strategies for dog oral health. So the statistic from an earlier slide stating that more than 50% of owners never have brushed their dog's teeth is conveyed here in a Loop global survey that had more than, I think, about 2,400 respondents that were representing 6 countries, and more than half of pet owners are saying because they don't brush the teeth because it's just too difficult. And I have 2 dogs of my own and have had 2 in the past, and I can attest to it not being the easiest thing to do for either the human or the dog. And it's usually not until a dog has a serious dental issue that owners will start to finally follow better dental hygiene routines. But at this point, a lot of uncorrectable damage could already be done. And I'm sure that any dog owner like myself, who is mindful of this issue, knows that there are a lot of dental products on the market, like chews, water additives, wipes, specialized diets, and supplements like probiotics. And all of these can be quite pricey, but really compared to the cost of having a professional veterinary dental scaling, it's not as expensive, but that's expensive, but also stressful for the pet and owner, since it typically requires anesthesia. And I think the cost is an average of about $300 US for a dental scaling. So between the prevalence of oral health issues in dogs, along with the limitations of the existing strategies, it shows that there is a need for a different approach to this area of health. And from that same Loop survey, representing the 6 different countries of pet owners, 94% of them believe that oral health does have a direct impact on their dog's overall health. And even though 89% of them did purchase a dog oral care product in the past year, it was with low satisfaction, even with 73% of them agreeing that these brushless products can help their pet's oral health. So why the low satisfaction with these products? Well, again, there's limitations to these. For example, the chews are really only just scrubbing the surface of the teeth. Treats with the herbal, the ingredients that are used in them are more so masking the odors. And then there are, some biotic, like prebiotic, probiotic, maybe some postbiotic products out there. But these are more just addressing the digestive component of bad breath. So the ingredient OraCMU actually starts at the actual source of it, which I'll get to in a moment. And then another interesting finding from this survey was the generational mindset shifts, where younger pet owners are looking more for proactive strategies instead of being reactive to the health issues that are severe, stressful, and costly, trying to avoid getting to that point. So all this talk about OraCMU, what is it? So it's a trademark, patented. I believe right now it has 9 patents. It's a strain of Weissella sebaria, which is a bacteria used in the fermentation of kimchi. And it was discovered at Konam Medical University in Korea. And that's why it's called OraCMU. The CMU is the name of the medical university. And it is a gram-positive strain. It has been clinically validated for oral health and bad breath in 9 human clinical trials and 2 canine trials, as well as 24 additional mechanistic safety and efficacy trials. It is isolated from, or was studied and isolated from the saliva of healthy children because of its ability to produce hydrogen peroxide, which we know for antibacterial and teeth whitening properties. So how does OraCMU work? Unlike current treatments, including dental scaling, that get rid of the bad bacteria, but also the beneficial bacteria, as you can see in the upper right, OraCMU is working on 4 main mechanisms. So first, it's producing hydrogen peroxide, and this naturally breaks the bacterial biofilms up. So essentially creating an uninhabitable environment for those bacteria that are producing VSCs. Second, it's producing bacteriocin-like compounds that directly target those bad bacteria so that the good strains can remain. Third, it serves as sort of a gas X for like a gas. I don't know if they have that in other countries, but like for people that have like gassy digestion. So basically it's blocking those VSC producing bacteria from emitting those gases with the VSCs. And fourth, it's able to quickly colonize in the oral cavity, so essentially leaving no room for the bad bacteria to live and colonize. So at the moment, there are 2 published studies in canines. So the first one from 2018 was a 6-week placebo-controlled study using 18 healthy 1 to 3-year-old beagles. The design is a little complex because there was a positive control group who received only a maltodextrin placebo, as well as a negative control group who received the placebo plus a dental scaling 1 week prior to the study. And the use of that positive, or the use of the positive and negative control groups were mainly to control for the effects of the maltodextrin placebo, because this was looking at oral health measures. And then 3 active groups. There was a low dose group with receiving 20 million CFU of OraCMU, a medium dose, which was 200 million CFU, and a high dose at 2 billion CFU. In these doses were administered to the dogs by being mixed with a saline solution that was applied to the dog's gums using a syringe once daily. So this study included an organoleptic evaluation where the dog's breath was assessed by a researcher who was 2 centimeters away from their mouth. And even though I'm a dog lover, I'm not sure if I would volunteer to do this job. But the study measured total and individual VSCs using that oral chroma gas chromatograph, as well as clinical indicators, including calculus or the mineralized plaque, and gingivitis index, which is a scoring system based on the amount of gum inflammation and bleeding upon probing. So getting into the results of this first study, so in the blue box on the figure to the left, you can see as early as week 2, the low dose or 20 million CFU group had significantly better breath scores compared to the placebo group. And in this study, the placebo group, as I refer to, is the positive control group. And by week 6, all of the doses showed this significance. And this is also conveying that there might not be a dose-dependent effect, since the low dose group actually had the quickest significance for that measure. So for total VSCs and methylmercaptan, all doses, all 3 active doses, had significant reductions as compared to placebo at 2 weeks, and these remained significant until the end of the study, which was 6 weeks. I didn't include the results for the dimethyl sulfide VSC, although this was significantly reduced versus the placebo for the low dose and the high dose group at week 6, at only week 6. And then for the hydrogen sulfide VSC, this one did not show significance between groups. And lastly, only the high dose group, so the 2 billion CFU, had significant improvement in plaque index versus placebo at the 6-week mark. And I'll touch on that in a little bit when I go through the potential claims for this ingredient. And for calculus and gingivitis index, there were no significance between groups. So the second study, it's really the same design as the first one, just a little simpler. So the bullets that are in gray are exactly the same as the first study, so I won't go through all of them again. But the main difference here is that the study started with a clean slate because all the groups of dogs received the professional dental scaling 1 week prior to the start of the trial. And again, the same 3 study groups, a placebo, a low dose group at 20 million, and a high dose group at 2 billion. I'm sorry, it's not the same 3 groups, but they didn't do a medium dose. So this one also had some measures that were not in the first study. So in addition to the ones that were in the first study, this study included looking at the colonization of the ingredient in OraCMU, which is Weissella sebaria, 5 periodontal pathogens, which are bacteria that contribute to gum disease, including those 2 I mentioned earlier, F. nucleatum and P. gingivalis, and 2 karyogens, which are bacteria that metabolize sugars, demineralizing the tooth enamel, which then can lead to cavities. So unlike the first study, but possibly because all of the dogs in this study started with the dental scaling, so at the clean slate, at the 2-week mark here, only the high dose was significantly improved versus placebo, whereas in the first study, the low dose was significant versus placebo. But at weeks 4 through 6, the 20 million or the low dose group also showed significance compared to placebo. And for the measurement of total VSCs, only the high dose had significance versus placebo from 4 to 6 weeks, whereas the low dose and the high dose had significant improvements in methylmercaptan levels the last 2 weeks of the study. In these differences from the results of study 1 are likely due to the various time frames that it takes for the different VSCs or the VSC producing bacteria to recolonize in the oral cavity. All right, so as you can see here, the placebo group actually showed worsening of the measure, like the plaque index, which is shown here. But this was the case for most of the measures as well, where the active groups were having improvements, even if they weren't yet significant versus placebo. But the placebo in most measures were experiencing worsening. So here at week 4 through 6, both groups, the low and high dose, showed significant improvements as compared to placebo for plaque index. And then lastly, for the oral bacteria count, at the 6-week mark, both doses had significantly lower levels of the periodontal pathogens F. nucleatum and P. gingivalis compared to placebo. So basically, this study is confirming also its ability to quickly and efficiently colonize in the oral cavity, with both of the doses having significantly higher amounts versus placebo at 6 weeks. Okay, so based on the 2 canine studies that we just went through, the main claims that we feel can be supported by the findings, I'm not going to read through them all because some of them are more so just different wordings of the same claims, but some of the key ones that are interesting in this area of health: reducing formation of odorous gas linked to bad breath, helping to produce or reduce bacterial production of malodorous gases, maintaining a balanced oral microbiome, supporting healthy teeth and gums, again by supporting a healthy oral microbiome, overall oral health, reducing plaque naturally in a less invasive way than commonly used methods. And then some of the preclinical evidence, which I didn't go through all of it, does convey that or CMU supports oral health by supporting a healthy inflammatory response in the gums and maintaining alveolar structure in plaque levels. And I did mention before that the plaque level, I think, was one parameter that was only significant versus placebo at the higher dose. So depending on the company's regulatory standards, they might need the higher dose in order to make that claim if they're desiring that attribute to it. So for formulating based on the stability studies and to obtain an efficacious dose through shelf life, we recommend an input of 2 billion at the time of manufacture. So that first study had significant parameters for all of the measures except for the 200 million CFU. So that's the dose we're stating as the dose you want at the end of shelf life to be remaining to make all of those claims. So again, based on the stability, inputting 2 billion would ensure that that dose is the 200 million is present at the end of shelf life. And these, this is just a mock label to kind of show how it can be labeled, but the suggested usage and dosage are just examples. An additional formulation notes, because it is a live probiotic, it needs to be kept away from heat and moisture. And the finished product for it would be stable at room temperature, depending on what other ingredients are in it. But that shouldn't need to be refrigerated. However, only the raw material for storage ideally would be kept in a refrigerator below 25 degrees Celsius and below 50% relative humidity. And basically, I know it's not feasible for everybody to apply, a syringe of it to their dog's gums, but however, it can be formulated into a pet supplement to get it in contact with the oral cavity. The longer, the better the chance that it will colonize and then, have the associated health benefits. And the dairy allergen, I just wanted to mention, is due to there's a milk powder that they use during as a cryoprotectant during freeze drying. And that's all I have for my slides. I'd be happy to answer any questions, and I did include my email here if you wanted to reach out that way for any additional information.
Well, thank you so much, Marie, for the really interesting talk. And I always think that we're so focused on the gut microbiome, everybody forgets that there's microbiome all over the place.
Yeah.
So let's go to a few questions for you.
Okay.
First of all, what's your take on focusing more on balancing the oral microbiome instead of just eliminating the bacteria?
I mean, essentially, it depends, I guess, what your definition of a balanced oral microbiome is. A balanced oral microbiome would be lower levels of the potentially harmful bacteria relative to the bacteria that, are either not having an effect or are having a beneficial effect. So I think you could say it either way. I think a balanced oral microbiome includes not necessarily fully eliminating the bad bacteria, but keeping them at bay so that they're not outcrowding the good bacteria, therefore causing the dog breath or other related health issues that can happen with their presence, and going into the bloodstream and causing liver and kidney issues.
Absolutely interesting. Next question here is, what are the potential advantages and disadvantages of incorporating a probiotic versus a postbiotic for supporting oral health?
So they both can have similar effects, and we are working on a postbiotic version of this because of the comparison of the advantages and disadvantages of using a probiotic versus a postbiotic, because postbiotic is not living, so it has less formulation limitations in terms of it can be combined with a lot more ingredients because you don't have to worry about keeping it away from those ingredients with higher water activities, just easier to work with. But right now we have the strong studies, 9 in humans and 2 in canines with the probiotic version of it. So yeah, I mean, there's a lot of advantages for both, but I think the probiotic is, people are kind of looking more at the whole biotic portfolio from the pre to the pro to the post, and seeing that there's benefits and downsides to all of them. So, I think having a probiotic in addition to maybe a prebiotic with postbiotic can give you a whole array of different health benefits. So yeah, we'll have to stay tuned on the viability of the postbiotic version of this. But again, the science will take time, and currently we have it on the probiotic version.
Yeah, excellent. And last but not least, what do you think will be the biggest challenge in helping pet owners to understand the concept of oral probiotics?
That's a great question. As I mentioned, there's just so many products saying that they're for oral health for pets, whether it be just for breath or teeth cleaning. I think it's just, how to get them to easily understand like what the difference between products are. are a lot of oral probiotics out there that, you know, a different variety of quality measures. You know, I can't speak for all of the probiotic products out there if they're putting in the appropriate amount of overage at time of manufacture, you know, unless you were actually to buy them and then, you know, see how close they are to shelf life and how many CFU they actually still have. But also, you know, I think dogs are you know, different in terms of their tastes. And I mean, one of my dogs is a chocolate lab, and she'll eat anything. And then we have, you know, a little greyhound mix from Puerto Rico, and she's super picky. So, like, you know, I know if it's a product with a lot of research and it's, you know, cost effective to the consumer, and the dog doesn't like it, what's the point in that? You know, I think it's a balance between educating the dog or the pet owner and having them understand how it's working, as well as their dog being accepting of it, and something that, you know, is easy for them to give to their dog, um, and also not too expensive. But also, I think too, you know, getting them to understand the potential dangers of ignoring oral health, especially when they're younger dogs and they don't really have as many teeth issues yet or gum issues. You know, I feel like it kind of happens fast. All of a sudden they start getting like the plaque buildup, and you know, I wouldn't want to have an oral or a dental scaling, you know, every year. It's just too stressful on the dog, and you know, as I mentioned, it gets rid of the good bacteria too.
I wonder if there's an inlet with a veterinarian here, especially with senior animals, where there's an opportunity to start talking about the importance of the oral microbiome to avoid anesthetic events in older animals might be a nice talking point. But I think too that there's a lot of knowledge, general knowledge in the public about probiotics. I think we just don't understand that there's bacteria everywhere. So I think we have to take those original communications and ladder them for the consumer a little bit. And a last question squeezed in here, I have to ask you, Marie. The question is there any research including organic acids to help the oral health?
I actually haven't looked into that. So I don't really want to try to extrapolate without really having looked into it. But that is something that seems interesting. You know, to your point, Kate, like, I think a lot of like consumers, especially if they're not, you know, big supplement users, just associate probiotics with digestive health. But as we're learning, you know, there's so many connections between the gut, you know, gut skin, gut brain, you know, and everything. So, you know, showing people the effects that like having a balanced microbiome is important for so many different areas of health aside from just digestion and breath or oral health.
Yeah, maybe somebody needs to contact Disney and they need to do some kind of like animated thing about all the bacteria that like all the different parts that live all over our bodies and how we swap them with our dog. I think it would be a fun movie. I'd watch it.
It would. I mean, if anyone has a connection to Disney, send them my way. We'll work with them because our marketing team loves to do like the animations that help people understand it. Because a lot of this stuff is, you know, technical, and you don't have a long time to explain it to a customer, especially if they're in the store. They're just looking at a label. So, you know, sometimes they're just looking at what's attractive aesthetically versus understanding what the product is, you know, and obviously the price tag is important too. But yeah, it's all about consumer education and keeping it interesting and applicable to their lives, you know, because otherwise they're out. They're not going to pay attention, or, you know, you've lost a potential consumer. So
yeah, I totally agree. Well, with that, thank you so much for the super interesting talk and really elevating where the oral microbiome sits today. I think that was really fantastic. I really appreciate it.
Great.
So,
thank you.
Yeah, thank you. But not least, we are going to go to our fourth speaker today, who is Dr. Sarah Martini from the University of Illinois in Urbana-Champaign. And she will be presenting today, Biotics and Manipulating the Gut Microbiome. Welcome, Sarah.
Thank you so much. And thank you for the invitation. I'm excited to talk today. All right, so we've spent a lot of time talking about whether it's microbiome in guts and mouths. And so I'm going to kind of take a little bit of that, wrap up some of the information that we've kind of already talked about, and then what it looks like possibly in our companion animals. And so I probably don't have to say this to many people, especially in this audience, but as more pets are entering homes, not only are more people bringing animals and adopting them, right, but they're having more pets in a home. More pets in a home means more money. And according to some really recent research data, it's kind of come out that more pet owners nowadays are willing to spend more money on things like vet care and specialized products with claims. I know as a pet owner myself, I always like to do the claims. And if I can pay a little bit more to add a little bit more to my pets' nutrition, their diets, their treats, I will absolutely do that. So guilty as charged. So kind of to bring together some of the stuff that we've talked about today, it's really been kind of demonstrating this relationship between nutrition, whether it's a dietary thing, a supplement thing, but also looking at the host and then the microbiome. And it's this beautiful relationship is the way that I kind of like to envision it as well. And especially in our companion animals, the diets that they often eat, they have the essential nutrients, the vitamins and minerals, but there's also extra things in there that can be considered microbiome targeted. And the beauty in especially companions, but also humans, right, is that you can actually manipulate the gut microbiome by using different microbiome targeted ingredients such as fiber. And really, whenever we're talking about gastrointestinal health or how do we maintain it, there's kind of four main parts to this definition. One, that the host has the ability to digest and absorb nutrients without any complications. So in other words, that they're able to eat and they're actually able to take away a majority of their diet, and whatever they don't, the microbes then get. Another thing, looking at the microbiome itself, is really that demonstrated stability, that there's no long-term fluctuations in the microbiome, because that can actually result in dysbiosis cases, for example, especially under clinical settings. Third here is that adequate barrier and really trying to maintain intestinal integrity, simply because anything that could bypass that intestinal lining can go right through the bloodstream and cause secondary reactions in other places like other organs, or really even systemic effects throughout the blood. And then finally, kind of where a lot of my PhD research really focused on was the microbiome's response and their resilience in face of disease. Now, granted, a lot of my research, as I'll kind of show towards the end, is really focusing on antibiotics and then how that can actually recover. But trying to manipulate the gut microbiome can be really difficult, as there's so many different kinds of microorganisms, not just that, but even on a volume basis, right? And so whenever we're trying to add stuff into a diet, whether it's a nutritional supplement or dietary supplement or diet type, we're trying to make a big change in a really big community. There's a lot of different things that the microbes are capable of doing, as we've talked about a little bit earlier. Dr. Perry talked about fiber. And so the microbes here are actually able to process nutrients that bypass host digestion. So for example, our fiber. The figure here on the right just kind of goes to show a little bit of a simplified version of the complexity of the microbes and what they're capable of doing. But they also have other functions that I won't quite so much touch on. But I will want you to take away from this is that different things such as the diet type, the age, genetics, and environment of that animal can influence that composition and activity. And a lot of times these are very complex microbial interactions that we're trying to look at, right? The microbiome is so complicated, so complex, but there's also some functional redundancy. But ultimately, especially when we're talking about trying to manipulate not only the microbes, we're actually manipulating things like their secondary metabolism or the metabolites that they're producing. And so I'm going to kind of summarize a little bit on defining different biotics, hopefully to kind of recap some of the stuff that's been talked about today. But especially in diets, there's a lot of prebiotic compounds that come from a lot of the fruits and vegetables, for example. But these specific prebiotic type ingredients are really selectively used by the microbes. And so these are the food substrates that we're giving the microbes, saying, hey, we want you to eat this. And not only just that, but produce a lot of the good things such as short chain fatty acids. But ultimately, the definition of this kind of comes from a pretty big organization called ISAP, if you've never heard of it. It is the International Scientific Association of Pre and Probiotics. This group is a huge committee of very, very, very smart people, and they sit down and they talk about definitions, and they are some of the coolest people I've ever gotten the chance to meet. But essentially, the definition of this is that it must evoke a net health benefit. And in human models, especially, prebiotics have been found to clinically improve things like insulin sensitivity, intestinal barrier, the reduction of pathogens or the presence thereof, as well as looking at some of that enterocyte sloughing off in the intestinal lining. Specific to dogs and cats, there's quite a bit of research out there, and it's going to get very complicated reading all these different studies, but kind of looking at from a very broad picture, what are they able to do? And so through the research, there's been beneficial shifts proven in the microbiome, improved nutrient digestibility, and even in a lot of clinical cases, the reduction of diuretic days. And so the amount of days that an animal is actually suffering from diarrhea, whether it's, due to a pathogen or due to stress, right? There's an improvement in overall fecal scores. Additionally, there's been research showing improvements, not just in nutrient metabolism, but also the production of different metabolites that are considered essential and beneficial for that host or for other microbes as well. And a few more more clinical focused things here is reduction in whole blood lipids and some serum-based studies, as well as overall improvements in clinical signs, especially in patients that are undergoing some type of metabolic or gastrointestinal issues. On the flip side, we've kind of already talked a little bit about probiotics, but these are the live microorganisms that whenever administered in an adequate dose, meaning at a high enough dose to have a beneficial outcome, they must have a beneficial outcome onto the host. And these can be a multitude of functions, whether it's from a metabolic, a cross-feeding relationship, kind of controlling some things that are going on in the intestine that we might not be able to measure, but those prebiotics can beneficially help in kind of shifting those types of conditions. Also, too, some of these probiotic species that are pretty commonly known, not just in humans, but in the pet food industry, are able to produce things like antimicrobials. So kind of preventing, some of the excessive pathogen either binding or buildup and accumulation over time. But there's quite a bit of limitations possibly, or some confusion, especially whenever we're trying to tease out some of these effects in our probiotics, such as, are these multi-strains? Are they species specific? What are some of those different outcomes that's kind of happening? But the big thing is going to be the dose response and also the functionality. What exactly is this probiotic species intended to do? And are we actually seeing that as well in our companions? Regarding some of that more clinical literature, there's been significant improvements in things like our fecal quality. And so as Dr. Perry talked about earlier, you're never going to get their nutrition talk without talking a little bit about the fecal quality here. But probiotics do have pretty high efficacy in helping with fecal quality and diarrhea scores, especially in animals that are undergoing antibiotics, which I'll kind of touch on a little bit later as well. But also, and especially in clinical cases, if there's a chance to look at histology, probiotics have been proven to help with improving histology scores and possible disease index scores in gastrointestinal signs as well. And so those can also be kind of referred to as the intestinal disease severity scores, or the SIBDI, if anyone's familiar with that. But also, too, probiotics do a lot of cross-feeding. And so one bacteria might produce something that can actually feed another bacteria. And so probiotics can actually be very good and very niche in assisting with trying to promote the other species that are going on in the gut or that are naturally occurring, such as our lactic acid bacteria or our short-chain fatty acid producers. But a lot of the limitation whenever it comes to clinical data is that oftentimes they are given antibiotics. And so trying to tease apart the effects of, did we see recovery because of antibiotics, or did we see recovery because of probiotics? It's a huge kind of area or perhaps limitation in the field. In a healthy animal, probiotics may be able to work great. In a disease animal, they might also be able to work great. But kind of on the bigger picture, what are those outcomes and what do they actually look like is kind of important too. Of more recent kind of terminology in the field is this term of symbiotics. It's a little bit of a confusing term, right? Trying to especially implement it too. There's not a lot of literature talking about symbiotics in dogs and cats. And so this all kind of comes from the human industry. So symbiotics are a blend of that prebiotic, which is that food for the microbes, as well as biotics, and they can either come in a synergistic or complementary symbiotic. And so the combination of the two, one focuses on feeding the host commensal microbes, and the other one kind of focuses on feeding the probiotics that are given in that. Oftentimes, these are very similar species, but trying to make sure that not only are they having a great outcome, but they're beneficially either colonizing or assisting other microbes in the process. But there's a lot of limited data on companion animals, so I'm not going to touch too much on some of the results here. But the main challenge for implementing these is that the food matrix, as we all know, is very complex. It's a lot of different things kind of all going in the diet. And so there's not a whole lot of clear understanding on the mechanisms of symbiotics or kind of teasing apart the effects of, is it the prebiotic or the probiotic that's having these effects? But the potential benefit there is that if we give both, they're going to have some kind of beneficial outcome. So kind of jumping towards the last one here is going to be our postbiotics. Post meaning after, and biotic meaning life or relating to life. So these are our previously live, then rendered inactive organisms that are considered kind of a culmination or an accumulation of all different kinds of things, like their metabolites, they can be with or without, or different cellular components, such as the cellular walls. Our postbiotics here, there's been really great but limited research in this area, but over time, the postbiotics do tend to have greater and longer shelf stability, and perhaps a potentially safer profile, especially in a pet food, that if they're not viable, they might not be able to contribute to spoilage, like Dr. Cutler was talking about earlier. And then our postbiotics, these might be a little bit more suitable for different applications and or different processing and manufacturing conditions. So they might have a better benefit, especially if they were to be incorporated into something like a pet food. But the limitations, especially with these postbiotics, one, even though that they're pretty new, it's that really evaluating that shelf life and the benefits and seeing if over time, the longer that the product is sitting there, if those same benefits were to be seen 6 months to a year later, if not sooner than that, kind of just depending on, how long the product is going to sit around for or different temperature conditions. But also, too, there's a lot of unknowns in our postbiotics as to which component of this postbiotic material is actually making it effective in a companion animal. Now, this is a table adaptation from a more recent review, kind of looking at postbiotics, but kind of the main picture of this table specifically was really looking at the postbiotic application. So there's a lot of intestinal microbiome modulation associated with probiotics or postbiotics, looking at different serum metabolomics, so modulating things on a more systemic level. But also what I kind of really want to touch on home here is the immune modulation, is that there's actually been great increases or attention to immune function in our companion animals, where research is finding that different nutrients and different things going into diets might be able to improve the host health, not just affecting the gut microbiome or affecting the serum of the animal or the blood of the animal, but also kind of looking on a more holistic or whole body view, is that these postbiotics are showing great success, which is very exciting in this field. And I know Dr. Perry kind of talked a little bit about this earlier, but as a pet owner versus a researcher, as I've been for at least the past 5 years now, is really kind of looking at how do we see these outcomes and how can we actually quantify them. So from an owner perspective, you can see things like the stool quality. If that animal is having diarrhea, you know very quickly that something is severely wrong. But also pet owners, they smell, right, whenever you go to pick it up. And so if there's a very pungent odor, there could be something going on. But from a laboratory side, it requires, at least a lab setting, if not advanced bioinformatics, but you can calculate and kind of quantify things like the fecal moisture. You can look at different metabolite concentrations. So really evaluating, not just what are they doing, but also how are they making these metabolites? What are they making? Is there something that's becoming a little bit more pungent smelling, like your phenols and indols? But also you can do correlations to figure out which microbes are doing what. And so from a laboratory side, you can do different microbial sequencing, but oftentimes that requires some advanced bioinformatics or advanced understanding of microbes. And if anyone has ever worked in research and received a sequencing file back, you would know it is a very overwhelming thing to look at. Imagine as a pet owner receiving a huge report back saying you have all of these different taxa and all these different bacteria in your dog sample. You're not going to have an understanding of what's going on, but kind of general understanding or general application can be really important and make that translatable to a pet owner. And so I've worked in microbiome for the past 5 years with my advisor, Dr. Kelly Swanson. I've learned a whole lot, but now it's trying to get to the point of educating pet owners as to why things like gut health are so important. And so kind of touching a little bit more on research and kind of a little bit of my background and where my biotic experience comes in is I worked a lot in functional distress through the administration of antibiotics. Specifically, I focused on metronidazole, which is a very potent, very powerful antibiotic that will go in and almost wipe everything out. And so kind of from a clinical setting, how can you achieve recovery? And it's always trying to bring in different dietary things, different strategies. But really, for the most part, there's 3 to 4 main areas. For the purpose of this talk, I really wanted to focus on dietary treatments. So those biotics that I just talked about, different diet food formats, hydrolyzed proteins, alternative proteins. This area alone, I can spend 20 minutes talking on. The second area here is going to be antibiotic administration. But if anyone has ever taken antibiotics before, there can be some very long-lasting and negative consequences. And in almost virtually all of my research trials, we've actually shown that the metronidazole effects alone can last 4 weeks, if not longer. And so antibiotics, while they can be great, have a lot of downsides. And then finally, fecal microbial transplants are becoming a very new addition into the veterinary field, but have been around quite a bit of time, especially in human medicine. But really, you can beneficially manipulate the microbes by doing different things, such as swapping out the diet, adding different nutrients in. You can add in antibiotics, that's going to shift them quite a bit, or you can give them fecal microbe transplants or FMTs, which can help with recovery. And so this is going to get a little sciencey, but the main point of this picture is essentially this was my final study that was recently published. But essentially, we can see that all the dots that are kind of in that pink were at the beginning of my study. We hit them with antibiotics, and this graph kind of just shows the separation or the differentiation of animals based on just alone antibiotics. So everybody in this group was hit with antibiotics. You see every dot as an animal has kind of shifted away. But the good news is that after 9 weeks of antibiotics, they kind of returned back to where they were. And so just alone, without even talking about the different dietary treatments that I gave them, the animals were able to recover just with time and a good quality diet. We've also tested this in vitro, so kind of a very closed system, not using a live animal, but essentially using 2 moderately fermentable fibers here, beet pulp and chicory pulp. They're pretty common in the pet food industry. Anything circled here is kind of that initial starting point. But after 18 hours of fermentation, kind of given these, they kind of shift in a different pattern. And so all of those dots in blue were samples that were prior to antibiotics. And so there was no antibiotic exposure. But anything in orange, it was the post-antibiotic. And so you expect a lot of differences. But the main point of this study, which was also recently published, was that the microbes, given good fiber sources or that beneficial fiber, for example, were able to shift in a direction that would have been similar to an animal that was not treated with antibiotics. So really just kind of proving that you can beneficially manipulate the gut microbiome with either dietary fiber in this case, or you can also manipulate it using any of the other biotics that I've already talked about. And so with any point in kind of bringing this back to the pet food industry is that biotics are not only everywhere, it's that they're not going to go away. And how, as an industry, can these be adapted or implemented to those younger pet owners, the older pet owners? How do we make this translatable to them to say, like, this is some good stuff, right? This is what we want to see more in the pet food industry. And so there's a few different applications, and it can be an easy thing, a more difficult thing. It kind of just depends on, the pet owner and what they are willing to give or what they're willing to do. And so kind of like Marie already said, if an owner is willing to give a syringe to a pet, right, that can be a challenge if a pet owner is not quite interested in that. But feeding it as a diet or in a treat or as a liquid topper, a powder topper, there's all different kinds of ways that you can bring this back and make it applicable or make it possibly a little easier for that pet owner to actually give them this food or give them these ingredients. And so kind of to wrap up, I really wanted to give a shout out to Drs. Wilson and Swanson, as they did a very beautiful job actually doing a review on different biotics and the microbes. And I would highly encourage anyone to actually take a read if you have access to scientific literature. But essentially the main point and a really great summary to this entire presentation is that biotics can promote the commensal species and the good guys that you want to see. They can beneficially increase metabolites, right? But also too, they're able to beneficially affect that integrity of that intestinal barrier. So making sure that everything is not only healthy, but it's staying kind of where it needs to. It can also manipulate that gut. And so kind of looking at a pH perspective, you don't want too sensitive, you don't want high acid, but you also don't want something that's, not going to be regulated and can actually stimulate growth. But also these biotics are able to help with stimulating the immune system, kind of providing some of those beneficial antimicrobial compounds and things like that that can ultimately benefit the pet themselves. And so the main summary, if I had to leave you with 4 words, I guess 5 here, it's that the biotic and microbiome interaction is complex. Like, we still have so much to go in this industry. The science is always coming out. It's always changing. There's always new innovations. And this is a really exciting time to kind of be joining into the pet food industry and seeing where things go next. But with that, I'd like to say thank you for listening, and I'm happy to take questions.
Great. Thank you, Sarah, for the really entertaining overview of biotics. Pretty good. It spoke really fast because there's a lot. I'm incredibly surprised how much you fit in to that period of time.
Thank you.
So,
It was honestly kind of a challenge, right? This is such an exciting area, and you know my advisor very well. How do you not cover everything? Like, it's a very exciting field. And I'm excited that I got to share as much as I did. So.
Yeah, you did great. I really liked it. I really like how you present too. So, couple questions at the end of the day. Do you think that processing methods like extrusion influence how well biotic ingredients work?
Absolutely. So processing, or really extrusion in general, right, is a very high heat, high pressure. And so probiotics, being those live microbes, might not be able to survive a lot of those conditions. It can actually render them inactive and leave something like a postbiotic. But in prebiotics and different dietary fibers, they might actually not only benefit the host, but it makes that diet a little easier to process and actually manufacture, because a lot of those fibers can actually bring that diet together. Think about like baking a cake, right? Like, you want everything to kind of come together, but in the wrong circumstances, they might kind of disintegrate, or they might not be able to work as well as you want them to. And so absolutely different processing conditions, especially temperature and pressure, will make a huge outcome, for better or for worse, especially if you're trying to use probiotics in something like a baked treat or a different, like a diet, for example.
Sarah, to build on that, do you think that we're at a stage in the industry where we're not going to keep trying to put everything on kibble because of all the different formats that we have? Mm-hmm. Do you think that we'll haul back and all these sensitive ingredients like probiotics will go to supplement?
I think that with how quickly the pet food industry has evolved in bringing in all these different compounds, I don't think it's ever going to go away. I think we're just going to get a lot more creative in how we put these into pet food products, whether it is a diet or as a supplement. Mm-hmm. The supplement industry alone is worth a lot of money. The supplements are always going to be there. There's always going to be more. And I think from an ease of convenience, if it's not a treat that I can give my pet, if I can give them a diet that has it, an all-in-one bundle of joy, I think that's where a lot of the consumer and that ease of, putting it into their lives is going to be. So as much as we see these fresh diets that have a little bit more limited ingredients, it might be great for some animals, but for a pet owner that says, I don't want to add, these different toppers and things, perhaps, an all-inclusive diet might be of interest. And so as we continue to grow and evolve and the diet formats continue to grow and evolve, I don't see that going away. No.
Yeah. It's like somebody said something very similar. I think it was Sarah Cutler, about a diet. If a diet isn't, you can have a great diet, but if it isn't palatable, I think that's what she said. And in this case, if we don't understand the consumer, you can try to tell the consumer what to do, and it will 110% of the time backfire on you. So what you need to understand is what they want, and then somehow get in. But I agree with you. Convenience is we all seek convenience, right?
Agreed.
And I think this is extremely appropriate considering that you've just finished your PhD. Which area of biotic research do you think needs the most attention now?
I love this question. So there's a lot of definition issues, I'd say, right now in the literature talking about symbiotics. I do really think that they have great potential, but if you're trying to tease apart, what's causing the outcomes that you're seeing, I really think that symbiotics could be a great area to invest in research. The applicability is kind of limited, right? Because those are probiotics. But the kind of caveat is, well, why not do both and have a heat-killed one and invest in postbiotics? And so from a financial growth perspective, I think postbiotics has a really great trajectory. But as a scientist, I also kind of want to see a little bit more on that symbiotic side. Like, what is going on in those specific products that's driving those changes? We have prebiotic literature and then we have probiotic literature, but we don't have a lot of literature that puts those together and seeing what happens in that relationship that's kind of going on. And so I definitely think that there should always be more research. I mean, if funding was unlimited, we would not be here today. But I really do think that syn and postbiotics are the biggest areas for growth in the research market right now, especially because they can be very easy to put into a food or a supplement.
Yeah, and what you're speaking to is mechanism as well. And this is one thing I think we get caught up a lot with this in the pet food industry, where we want to go right to a product and what the benefits or the detriments of that product is and research on that product. And sometimes we have to haul back and do very mechanistic work that has nothing that we're going to feed a dog is going to go to market, but what we're feeding them will help us understand the mechanisms, and we need controlled research to be able to do that. And of course, people need to be interested in the discovery part of this too. So I encourage all the pet food people out there to consider funding these kinds of research. Okay, another question: how does veterinary prescription diets influence this space, and how to be careful in creating such diets while making sure we are keeping all the biotics in mind when we're formulating?
This is an awesome question. So the first two studies of my PhD were actually kind of looking at veterinary GI diets specifically. And I think that these are very great. But the major limitation that me as a researcher, but also as a pet owner, has come to realize is that these veterinarian prescription diets, you have to go to a veterinarian and get them to sign off on for you. You're not going to conveniently find it on a shelf. And so if you have a very good open relationship with your veterinarian, this is obviously something you could definitely talk about at any point in time. But sometimes getting those might be a little bit more difficult and a little bit more challenging. I really am a huge supporter of any gastrointestinal diet. I love the fiber. My advisor would be so proud of me for saying that. But I really do believe that a lot of these GI diets have those beneficial fibers. When it comes to formulating and making sure that you have these diets that have high enough volumes of biotics, it can get a little tricky, right? You don't want to overfiber a diet. It's going to make it way less palatable. No one's going to want to eat it. And then at that point, you've probably wasted a lot of money on a bag, right? Mm-hmm. And so having a moderately higher fiber content without overdoing it is probably going to be my recommendation. I love fiber, love to see it. My dogs get it all the time, right? But in formulation, you probably are going to come across a lot of challenges with putting that into a diet, or something like trying to make sure that like the kibble stays together. If you have too much fiber, it's all going to just fall apart and you're going to have a bag full of fines. And so trying to find the best of both worlds, I think it kind of comes from a sweet blend of fiber that all have different characteristics. But the biotics and kind of talking on the probiotics, it gets a little tricky and a little messy on the production side from my experience and from what I've heard from others trying to implement that and maintain those integrities. But yes, I do love the veterinary prescription diets. I think that they can be very beneficial.
So I like your comment about diversity once again, not only diversity in the microbiome, but diversity in the fibers that you choose to feed will help to promote that. Okay, and I think maybe the last question for the day, if you have to prioritize the use of different biotics, do you consider the nucleotides will be the best solution to enhance immune function?
Ooh, this is a challenging question. I wish this would have been in my defense. If I had to prioritize the use of different ones, I think there's a lot of great application on an individual level, but understanding that the more niche and refined that you get, you might not start seeing the same outcomes that you were probably hoping for. Nucleotides are very, very small, right? They're very tiny things. But if you're feeding those in a complex food matrix, what are you going to see? Adding specific ingredients in, I think, could be an interesting addition, especially if you're looking to target immune function or trying to improve that health perspective. But I feel like how far down into the biology and into the nicheness can you actually get in a diet? And also to kind of thinking on a consumer perspective, is that consumer or that pet owner going to understand what the purpose of that ingredient is? Because I know when I first started in the pet nutrition industry, or at least in pet food research and kind of the core classes, I was very overwhelmed by all the things that sounded like chemicals. So I can only imagine, as a pet owner, if you're reading things like, okay, why is this in my diet? But if you're intending to make claims, I think that can be very beneficial, but educating and kind of understanding why that's so important, I think would be a huge thing. But biotics and diversity, I'm here for it 100%. And if there's beneficials, to come out from this, that'd be awesome.
Yeah. So one more question came in, but you've actually started to answer it in your last question, which really comes to this idea about what to do with the overlay between biotics and precision nutrition. So will you get to a point where, or will we get to a point, and I imagine that I would have to think that humans will fire first, but where we're actually catering to that individual's microbiome. And that's the basis for a lot of those probably pre, post, and in some cases probiotic recommendations for that individual. So going right to individualized.
Yeah, I think you're right that the human industry is probably going to be the first one to really kind of start tailoring claims, and really talking with registered dietitians or RDs would be great, especially on that perspective. But we don't really have a lot of that in the pet food industry. We have diets that we say this might better suit an individual, or we have these supplements that we can also give them that we know should help. And so I do think that personalized nutrition, whether even as a human, but it's also going to trickle down into the pet industry, right? With things like homemade diets, where if you have a consultation with a nutritionist, you can kind of tailor different diets down to what that pet needs. Now, if you're looking at how do we tailor it to their specific microbiome, then you're relying a lot on the information to come back of that microbiome being consistent or translatable. Like I said earlier, the sequencing data can be very overwhelming. So at what point is it also overwhelming for the pet owner? Instead, if I were to receive a report back that says, based on this, your dog or cat might benefit from these types of fiber blends or this type of probiotic category, and kind of things like that. So I do think that personalized nutrition is a very invigorating topic, and I would love to see it. And I think that's, kind of on the horizon for where this industry might be going.
I think we'll just have a Karen in our pocket where we'll scan stuff, and it'll just give us an X or a check.
Yeah, exactly.
AI, it'll probably be everything. Yeah. It's going to take all the excitement out of life, right? Anyways, that's just me. So thank you so much for for the discussion today, Sarah, and for the outstanding presentation. I really enjoyed it.
Thank you so very much.
All right. As we close today's Pet Food Summit, I want to sincerely thank each and every one of you for joining us and for staying with us through the afternoon for a journey of learning and collaboration. A huge thank you again to our incredible speakers, Dr. Erin Perry, Dr. Sarah Cutler, Marie Parks, and Dr. Sarah Martini. Your contributions were absolutely invaluable. And of course, last but not least, to our sponsors, BioOrigin, Chema Nutrisurance, and Stratum Nutrition. Thank you for your ongoing support of scientific knowledge and innovation in the pet food industry. It's been a pleasure to host you all today, and I hope that you have a fantastic day. Take care.